In this video, we want to talk about describing graphs and their behavior. So we're going to be talking about things like increasing, decreasing, constant, maximums, and minimums. So here we have a nice little graph. It's a polynomial graph. And we can see that if I were to trace this with my finger, it initially is increasing and then it kind of peaks out up here and then it decreases for a bit and hits a valley, and then it starts increasing again. So that's what it means, increasing, decreasing. It's very logical, it's very intuitive that as you're reading from left to right, you're either going up or you're going down as you trace the graph. All right, so that's really all that it means. This fancy math notation, don't worry too much about that. As long as you have the general idea, that's great. Let's look at a specific problem that has some actual data points on it. So initially, again, it's increasing, but then I have this ordered pair here where it peaks, and it's negative 216. Then it starts decreasing, and we hit the low spot, a positive 2 with a negative 16, and then it starts increasing again. So for this problem, I would say that I have a local maximum. It's local to this area. If I just zeroed in on that section of 16, you notice it's not the whole ordered pair. The maximum or minimum is going to be the y value for the function. We do say that it occurs at a negative 2 at the x value, but the max or the min is always just the y value. So similarly, we could say in this little local area down here, we would have a minimum, so we call it a local minimum of, again, just the y value, negative 16, and it occurs at, in this case, x equals 2. We can also look at this one where I have, it's a piecewise defined function. It's got a couple different rules going on here in different shapes for different x's. So I'm going to draw in some dotted lines here to separate where the graph appears to be changing direction or changing what it's doing. So this first section here, I'm going to say that's constant, because if I look at this graph, it's not going up or down, it's staying flat. And then from this first vertical line to this vertical line, if I traced it, it's decreasing. Then from that point to the next one, I reach a peak, and that's an increasing section. And then the final section is going to be decreasing. So over here where I was asked to give the locations for those various things, I put constant from negative infinity, because you see the arrow, it's pointing down to the negative infinity side. So I read left to right, my intervals go left to right. So from negative infinity until I hit this value, which is, and I'm not looking at the y value, I'm looking at where I'm at on the x-axis, it's at negative 1. So it's constant on the negative infinity to the negative 1. The next section we said was decreasing, and that starts again at this dotted line and goes to this dotted line. I don't focus on the y values here. I'm saying from where to where on the x-axis as I'm going from left to right. Well, it's from this negative 1 until I hit here, which is going to be positive 1. So that little section is a decreasing section. So that's why it's listed there. And then this next section from between these two dotted lines, we're going to have an increasing thing. One more time, I don't focus on the y values here. I'm saying from what point to what point on the x-axis am I increasing. So it's from this point here, 1, until this vertical line, which is at x equals 4. So it's increasing on the 1 to 4 interval. And then finally, from this dotted line till as far as we want to go, it's going to be decreasing. So from 4 to positive infinity, it's going to be decreasing. The local mins and maxes have to be where I'm actually changing value or changing directions. So if I am looking for a local max, I really only have this one here, because in this section, I'm changing from increasing to decreasing. It's the high spot there. The local max is the 11, and it occurs at the 4, at the x equals 4. I don't consider this 6, a local maximum, for a couple reasons. Number one, it's an open circle, so that's not really even the function's value there. But the other reason is because it's not changing from increasing to decreasing. We do have a low spot here, and it is a place where we change directions, so I can consider that a local minimum. The minimum is going to be the y value, 2, and it occurs at the x equals 1. Hope that helps.